Good afternoon, welcome, thank you for joining. My name is Roger McCready and I'll be delivering today's webinar on water treatment solutions. Give you a quick summary of who we are, then we'll get straight into this. Here at Atlanta Pumps, we specialise in pumping gritty and abrasive fluids with a focus on critical processes where same-day solutions have real value. We're also the brand owners of EnviroHub, a range of temporary water treatment and water quality monitoring solutions targeted at construction, heavy industry and civil engineering. Today's webinar should be about 1 hour in duration, and then will be opportunity for question and answer at the end. There is a Q&A box. Please drop your questions in there and we will address those at the end. Likewise, any questions at the end you can drop in at that time. And then any comments, you can also drop those in the chat. Then we'll just wrap up at the end with some takeaways. So what we'll be covering off in this webinar is a background of legislation and enforcement. We'll be introducing EnviroHub, our water treatment brand. We're then looking at some treatment principles for industrial wastewater. We'll then be covering off Senteos, our offering for remote monitoring, continuous online monitoring. And then wrapping up again with compliance and legislation, which underpins all of this. So sites are now required to provide proof of safe water disposal. The Environment Agency routinely conducting water quality checks. Now there are a number of enforcement authorities within the UK. So the Environment Agency is for England only. Scotland, Wales and Northern Ireland each have their own. So SEPA in Scotland, NRW Wales and NIEA in Northern Ireland. And they'll typically be monitoring flows and volumes, also taking physical samples to check that on any pollutants in that water and ensure that any water that's being discharged is being done so safely and in compliance. And they enforce that by means of a discharge license. So I don't want to repeat a previous webinar where we went over discharge and abstraction licenses, but a license is a document from the enforcement authority that gives you consent to discharge water within certain limits. The typical parameters measured are suspended solids, pH, parts, oils and greases, and also flows. If that enforcement authority finds you in breach, they do have the powers to advise you, to request you make some changes. If they lose confidence in you, they can also direct you. And then ultimately, they can prosecute, they can bring a case against you for a breach. Incorrect disposal of water. So if you have breached your permit, if you disposing of water in an incorrect manner, that can have a number of consequences. So if we are discharging solids or concrete, that can, for instance, block drains. It can fill up rivers or waterways, which ultimately can lead to flooding. Chemicals, they could kill off local wildlife and trees. And all of that can obviously lead to a costly environmental cleanup, which no one wants to undertake. Now, penalties are the means by which the EA and other organisations enforce their permits. And this is a moving scene. Fines did used to be capped at £250,000. That cap has now been scrapped, and the range of offences that they cover has also been expanded, meaning that the EA has more tools with which to hold the water industry and others to account. Now, if you really get it wrong, or if you're a repeat offender, you may end up in the Crown Court. And again, there is unlimited fines there and up to 2 years imprisonment. So the range of offences that can be punished with a fine can include breach of permit conditions, discharging to a river or the sea, for instance, sewage overflows, storm overflows, or it could be an illegal discharge. For instance, you don't have a permit in the first place. And there are a number of, as part of the changes, the penalty, part of the uncapping of the penalty is the penalties are now issued in proportion to the size of your organisation and also the nature of the offence. So I think a lot will be aware recently, Thames Water had a significant fine of £104 million. It was a fine in proportion to the size of the organisation and also the nature of the offence. So it's a significant amount of money. And it is a constantly changing scene. I was reading a government document the other day It was updated on the 31st of March this year. So there's lots happening, lots of change, and it's very important to be up to date and keep on top of what those changes are. Now we'll have a quick look at what is EnviroHub. So EnviroHub was launched by Atlantic Pumps to give sites a simple and stress-free methodology for sites discharge, concentrating on the quarrying and heavy industry markets, including civil engineering activities such as tunneling and piling. It is an Atlantic Pumps brand and is used both here in the UK and also overseas. So we export and also manufacture under license to serve export markets. The typical flow rates that EnviroHub deals with is anywhere from, at the low end, sort of around about 2 cubic meters an hour up to a few hundred cubic meters an hour. That's a sort of ballpark where we see EnviroHub operating. We developed a modular range of products, enabling sites to scale and simply and easily implement them. And alongside of those treatment products, we've also developed a cost-effective control and monitoring solution. We'll be touching more on this later. As we mentioned, it's a modular system that treats or monitors the common pollutants. So the common ones, there's flow rates and volumes, turbidity for suspended solids, pH, temperature, and then there's a whole range of other parameters such as DO, that's dissolved oxygen, ORP, conductivity, COD, BOD. The list goes on. There's a whole range of parameters that can be measured, monitored, and controlled using EnviroHub, and it does provide that robust method of control and also a simple and effective means of continuous online monitoring and data storage. Some of the benefits of EnviroHub, again, the modular is featuring quite a bit here. So what we mean by this is if your site is scaling, or if your project is scaling up, maybe there's changes, it's very, very easy to effectively bolt in additional treatment tanks, additional treatment processes. Very, very easy to just bolt those into the system to scale as your organization or project scales up. It can also, if we can reuse or if we can reduce truck movements, if for instance we've been tankering water off-site, tankering is a very, very expensive activity. You've got the lorry movement itself, and you've then got the treatment of that water off-site, and that whole process is very, very expensive. So if we can treat the water on site and discharge it directly, we've cut out the cost of that treatment, those vehicle movements, and obviously also improved our CO2 footprint because we've not got those vehicle movements. If we can clean that water up on site, can we recycle it? Can we reuse it elsewhere? It's very well worth looking at if recycled water can be used. So some applications might be wheel wash, maybe any other washing processes, maybe some form of dust suppression, but essentially anything that if you can reduce reliance on fresh water, reuse cleaned water, that's an obvious benefit. It's a circular economy and you're not paying for that fresh water each time. It also simplifies compliance with planning permission. So for instance, if you are needing to scale up, put in more tanks, put in more capacity for a treatment system, traditionally lamella tanks or settlement tanks or reactors vessels, there might be a concrete tank. It's significant civil engineering, a lot of cost, a lot of expense, and a lot of red tape to go through with planning permissions, conditions, and so on. Whereas if we can simply put in a modular temporary system that even can stay there going forwards, it doesn't carry that same burden of red tape and so on. Continuous online monitoring we've also mentioned, so that is another benefit. It's real time, but also it's historical, so we have up to 10 years worth of data stored. So if there's been any breaches, or even you just want to look back at history and prove that there's been no breaches, you can look back and see that your site has been compliant over that period of time. And finally, it can also step in and take over where a lot of human interaction if need be. So it can automatically start a pump, it can automatically stop a pump, it can change a valve. So for instance, if our quality of the water is changing, perhaps the pH is going out of spec, perhaps the solids loading is increasing, EnviroHub can intervene and can prevent that water flow from going off site, making it stress-free for you and enabling you to concentrate on what's truly important to you and your organization. So I'll just cover off some of the typical pollutants that we find within industrial wastewater. So there's three broad categories. We have pH imbalance, we have solids, and then organics. So in relation to pH, it could be too high or it could be too low. Now, if it's outside of a safe boundary, that can be harmful to people, that can be harmful to the environment and aquatic life. It can, if we're discharging very high or very low pH water into a watercourse, that can have a significant impact on that water body. Solids, there's three categories of solids, and that's gross particles, fine particles, and colloids. Now, gross particles, they're heavy, they will drop out directly by gravity. If you imagine you had a bucket full of water and some small stones in it, you're stirring it up with a stick, some of those stones might get agitated and carried up with the flow of the water. But the moment you stop stirring, they'll drop straight down to the bottom. That's gross particles. They'll drop out straight away by gravity, and we don't need to do any further method of treatment. Fines, these are smaller particles, a few hundred microns in diameter generally, and they'll often still settle out by gravity, but they'll take a lot longer to do it. And that's where we may need to intervene with maybe chemical dosing to speed that up. And then we finally have colloids. Now, colloids, by their very nature, they will never settle. The reason for that is the particles themselves, the colloidal particles, they have a negative charge, and they are effectively all repelling each other, which is why they remain in suspension, and they won't settle out. Now, obviously, we need to remove solids from the water flow, because if we are discharging excessive levels of solids, they could fill up drains, they could block sewers or waterways, which can in turn lead to flooding or other impacts. Obviously, solids can also make water appear dirty. And it's probably a good point to also clarify what's perhaps sometimes a myth between turbidity and suspended solids. So a discharge license will reference suspended solids or total suspended solids, and that's measured in milligrams per litre. However, there's no sensor that will directly measure milligrams per litre. To get a discrete value for that, you need to take a sample, carry out some lab analysis, and actually weigh those solids to get a true milligrams per litre measurement. However, we can use turbidity as a proxy measurement. So turbidity measures how cloudy the water is, and it very nicely correlates to total suspended solids. So we can take a reading of a sensor using turbidity, we can apply a conversion factor and give a very close estimation of what our total suspended solids are. Finally, moving on to organics, we've got fats, oils, and greases, and solvents. And fats and greases, they can solidify, particularly if you are tipping hot fats down the drain, for instance. They can cool in pipes, they can then solidify and cause blockages that can be harmful to wildlife. And I guess most on this call would remember the Thames Fatberg, a sort of a compilation over time of fats and greases building up into a very, very large blockage to a sewer. We'll now look at treatment principles for pH correction specifically. So we've got, as we've mentioned before, we could have high pH, we could have low pH. High pH, typically, in our experience, where we've been interacting with industrial wastewater, that's been cementitious water. It's perhaps from concreting or grouting activities. It will have a lime content, which is giving rise to that high pH. There are obviously other sources of high pH, but typically where EnviroHub has got involved, it's been where there's been a lime content to that water giving rise to that high pH. Low pH water, that could be naturally occurring. I know of some quarries within the UK where the groundwater is naturally pH 3 or 4, and that needs to be treated, that needs to be raised up to a safe limit to enable discharge off-site into surface water. It is really, really important to get your pH in a good and safe range first, because that can affect the rest of the treatment train, and we'll come on to that in a touch. There are a couple of methods of treating pH to correct it that we use. One is gas and the other is liquid. So we'll explore gas first. We generally use carbon dioxide as the gas. And the reason for that is carbon dioxide, it's an inert gas, it's safe to use, it's safe to handle. And carbon dioxide in water forms a weak acid, carbonic acid. How we dose it into the water is through a device called a sparger, which is a ceramic device, and that's generally either a disc shape or tubular, and it's porous. And when gas is applied at pressure, it will generate lots of small bubbles into that water. Those bubbles attach themselves to the lime particles in the water, and that reaction neutralizes the pH. Being a weak acid, the carbonic acid, being a weak acid, it naturally buffers around about pH 7. So that is excellent for control because it's really, really difficult to actually overdose. If you do put too much CO2 into the water, essentially all you're doing is wasting CO2. You're very unlikely to be able to actually overcorrect that water to unsafe limits, sort of like the far side of that boundary. Acids and alkalis, however, a little bit of a different story. A lot more hazardous to store and control and use. You've got the COSH aspects of that, and again, it's a chemical reaction. You'll be dosing an acid to reduce your pH, or maybe dosing a base to raise that pH. And you have to be very careful with that, not to overdose through a thing called alkalinity. So alkalinity is how resistant to change of pH the water is. So for instance, if water has high alkalinity, it'll be very resistant to changing pH. So that's very nice and controllable. You can add acid or base and it will scale back in a nice controlled manner. If, however, you've got low alkalinity, you could put a low dose of an acid into an alkali solution, and that could swing wildly, which can then lead very easily to overdosing. And that can also sometimes be byproducts of reactions as well, which then need further treatment and processing. Some of the acids we would use, we might use hydrochloric acid, sulfuric, citric acid. For the base, a common one that's used is caustic. And I'm sure everyone's familiar with the pH scale, but just to bring it to life, this red line here represents the typical pH of concrete water, so it's up at 13. And this orange box here denotes the typical discharge limits that we see on discharge licenses. Not all discharge licenses are created equal. I have seen some that enable discharge up to 11. That would typically be into a sewer. But really where we want to be aiming for is somewhere in that 6 to 9 boundary. Now we come on to treatment of solids, how we remove those solids out of the water. So again, there is 3 stages here. We have what we call coagulation, flocculation, and then clarification. Now, coagulation, this is typically needed when we've got the colloids. So our gross particles will have dropped out. Our fine particles, they may need a bit of encouragement as well. So fine particles and colloids. And we dose what's called a coagulant to get rid of the bulk of the contaminants. How that works is we destabilize the water by dosing the coagulant. The coagulant has a positive charge on it. So you remember those negatively charged colloids in the water. Positive and negative attract. So the coagulant, when it's dosed with a rapid agitation, so it needs rapid dispersion into the water, they will attach themselves to those colloids. That destabilizes it and leaves it with a neutral charge and also slightly sticky on the outside. We then move into the flocculation. So this is where we're wanting to encourage those destabilized particles to bump into each other, clump together, and form flocks. So the coagulation will have formed pin flocks. They are slightly sticky. We now just need to cause those to bump together and form larger flocks. We sometimes need to add a second chemical at this stage, a polyelectrolyte or a polymer, sometimes also referred to as a flocculant. Essentially, that's a glue that will enable those flocks to stick together, form stronger bonds between those pin flocks so that they don't break up so easily, and also enable larger flocks to form. The larger that flock, the easier it will be to settle out. The final stage then is clarification. Now, there's a couple of methods of clarifying. We have flotation, which is where we'll use air, such as dissolved air flotation, to raise those particles up to the top where they can be skimmed off, or we have sedimentation. And sedimentation is what we use within an EnviroHub. So that's where we're using gravity to take those large flocks and allow them to settle down to the bottom of a tank. That will then give us a cleaned water on the top, a supernatant, and then a settled solids sludge. And you can see on this beaker here, you can see this is settling, we can see the grading, we can see the water up here is cleaner, and after this has been left for a period of time, we'll have a supernatant and a settled solid sludge. Another point to mention is the ideal conditions for coagulation. So you remember I mentioned that it was important to have pH at the beginning of the treatment process. The ideal conditions for coagulation is slightly acidic. So if we have had a high pH, we want to get that down to 7, maybe even 6.4 pH. And that will be the ideal conditions for coagulation. If we are outside of, if we're very low pH or very high pH, the coagulation process will not have the same effect. So now I'm just going to do a dive into some of the products available within the EnviroHub range. This here is our concrete washout product, which is typically used for mixer truck washouts, concrete truck washouts, construction sites. We'll do a quick walkthrough of how this works. So we can see the mixer truck is backed up here. I'll just put my laser on. The water is discharged into this bund here. So this is what we call a concrete washout product, CW01. And over on the right here, we've got what we call our CT01. That's our pH correction tank. How that works, we can see we've got a cutaway here. Water will enter the top of the bund. This here is a filter bag. So this will catch all the aggregate and sediment. And then some of the fines will percolate through, and water can percolate through that to a bund on the bottom. Once that bag is full, that can be lifted out and replaced. Water on the bottom can be pumped then through to the pH correction tank, which we've got here. This houses the controls, it houses the carbon dioxide. We've then got an onboard pump and a washdown hose that we can use for then subsequent washdowns. So here we have the tank itself. So water will come across from the CW, concrete washout, into this tank here and fill it up until a float switch says the tank is full. You can see the sparger here. This is where the CO2 will be dosed. So there'll be an onboard pH probe which will recognize that the water is high pH. It will dose CO2. The agitator will ensure that that's mixed in thoroughly. And then once that pH has been corrected, that water can then be used either for discharge or for subsequent washdown. So we can have like a closed loop. Moving on to the pH correction tank specifically, we do have a couple of products within this range. We have the CT01 that we've just seen and discussed. We have the CT03. So those numbers 01 and 03, they relate to the volume of water. So 01 is 1 cubic meter. The 03 that we can see on the screen here, that's 3 cubic meters. And then we can also see here a couple of other letters, the GU here on the slide. So what that means is G stands for gas. So this tank is using gas for the means by which it corrects the pH, and U is for unidirectional. We're changing the pH in one direction, which in this case would be down from a high pH down to neutral. The alternative is L, which is liquid. So that's where we'd be using an acid or a base to correct the pH. And again, the U would be unidirectional. The converse of that would be B for bidirectional. Within EnviroHub range, we just currently have these unidirectional products. How this works, we have a control panel in here that the in-feed pump would be connected to. So that would be controlled by the in-feed pump would fill up this tank here. Once full, the pH would then be measured, the in-feed pump would be switched off. pH will be measured, and assuming that that pH is indeed high, we'll then call for the sparger to dose CO2. That'll be mixed into the water, and once that has neutralized, the discharge pump can then switch on and pump that away, either for reuse or potentially down the sewer or elsewhere for disposal. The tank, once it's drained, the in-feed pump can then kick in again and fill the tank, and it will essentially repeat on that batch manner. Next up, we have our treatment unit, or TU, which comprises of a bund for 2 IBCs, so typically our coagulant and our polymer. It also houses the dosing pumps, it controls the agitators in our treatment tanks, which we'll be coming on to next, and it can also control the in-feed pump to the treatment tanks. So that's it's essentially the control for the whole system. Moving on to the treatment tanks themselves, we have 3 tanks within this family: the TTO3, the 05, and the 10. And again, those numbers correspond to the volumes of water held. So this tank on the screen here is our TT10. That will hold 10 cubic meters of water. So how this works is water will come in through this end, typically through a flow meter, which will then be wired back to the treatment unit, and that will control the dosing. And water then enters this first chamber here, and this is where we have our fast mix agitator. So remember, coagulant needs rapid dispersion into the water. So the dosing hose will come into this tank here, and there'll be rapid agitation of that water, enabling that rapid dispersion and those reactions to happen, those pin flocks to form. Water can then pass into the main flocculation chamber of the tank. This is where we have our slow mix. So that's the flocculation, where we're gently swirling the water and causing those pin flocks to bump into each other and form larger flocks that can then settle out by gravity. The opposite end of the tank, we then have the outlet, where water can be discharged by gravity either into a settlement tank, or more typically within EnviroHub into a lamella tank. This here is our range of lamella tanks, so what we call our HL tanks. HL stands for high lamella. And again, we have a range of sizes within this product family. We have the HL10, the HL20, the 40, the 50, and the 150. Now, these numbers don't relate to the volume, but rather the surface area or equivalent surface area that a tank has in comparison to a standard settlement pit. So for instance, an HL10 has 10 square meters of settlement area or surface area. And an HL50 has 50 square meters of surface area for settlement. The different size of tanks are sized to suit different flow rates, and we're also governed by sedimentation velocity, so how fast our solids are settling out the water. We might have a low flow rate, but we might have a solid that settles very, very slowly. So we might need a larger tank than a higher flow rate with solids that settles out quicker. So that governs the selection of tanks. We also have the HLR series, and that's where we have a cone bottom and a rake that maintains the agitation of that sludge should there be a danger that it's going to pack too tightly to actually drain the tank. So just to touch on the differences between lamella tanks and settlement tanks. A standard settlement tank, we've got here typically how they work. We've got an inflow and an outflow, and if we've got a particle here, it's got to travel all the way across the tank to exit. But if we're wanting it to settle out, it's got this full depth of the tank to settle before it's settled, because if it's not fully settled by the time it gets across the tank, it can be carried out with the flow. So we've got that depth of water to settle. Whereas over here, if we look at the inclined plate lamella, we've got a large surface area here. By using inclined plates, that surface area can be made very compact into this small area here. Now, what that means is, if you've got inclined plates, the vertical distance that a particle has to drop if it's traveling in a water flow up between those plates is vastly reduced. So it's got much, much less distance to settle out. And that enables much more efficient and effective use of the space and for settling out those solids. So we'll now just have a quick look at how a whole lamellar tank system works. So we've got the infeed coming in here, water enters the lamellar tank through the infeed here and back down through the inlet chamber. The flow is then directed through into the main body of the tank. Flow is then directed up between the inclined plates and then exits via an overflow weir. We've got our cleaned water exiting here. Any heavy solids may settle to the bottom directly. Any other lighter solids that may be still carried by flow of the water will be carried up through the inclined plates. But as I mentioned, there's a very short distance for them to settle vertically before they land on a plate. Successive solids landing there, flocks landing there, they'll clump together, they'll grow, they'll then become heavy enough to then slide down the plate and drop into the sludge volume at the bottom. That operates as a continuous cycle. The sludge itself does need to be drawn off the bottom periodically. That can be either a manual process, open the valve and allow the tank to drain by gravity, or a pump can be connected along with suitable control means to take that sludge out at suitable intervals. We now move on to our monitoring products. Now, we've corrected our pH, we've taken out the solids, but we need to prove that the discharge is indeed compliant. So that's where our range of monitoring units, or MU, comes in. So this, we've got a range from to suit pipes of 2-inch diameter up to 12-inch diameter. And how that works is we've got this flooded section of pipe, and we have the probes in here, such as pH, turbidity. We've also got the flow meter, and we can measure the cleanliness or the quality of that water as it's passing through. We can then report that up onto the cloud, which we'll come on to shortly. We can also use that to control the system. So for instance, if there's been a problem, we can cause it to intervene and shut down the system. We also have another product available here, which is our floating MU, and this monitors the water body directly. So for instance, if you're wanting to dewater a lagoon, that can sit directly in the lagoon and control the discharge pump directly. Now that segues us neatly into the whole control aspect. So the EnviroHub control module is what governs the operation of these. So we can see on there CMO2, we're on our second generation of control module, hence by CMO2. What the control module is, it's a PLC that's been designed specifically for water treatment and water quality monitoring. It boils down what would traditionally have been a whole control panel full of equipment down to one small unit. It can carry out a range of functions, so it can carry out monitoring, that's automatic uploading of water quality parameters to the cloud. It can carry out process control, so it's got integrated control of pumps, valves, and chemical dosing. It's modular, so it's got interchangeable input and output controls. So we've got that flexibility for system configuration and upgrades in the future. Very, very simple and rapid to deploy, simple connection of sensors and actuators, and low stress management. So coming back to the whole goal and aim of EnviroHub being that stress-free solution, it connects to the online portal for viewing of that data online and receiving alerts from anywhere in the world. So we've got a bit of a look behind the hood here at what a CMO2 looks like. So what it consists of is a core board, which is largely obscured from view here, a core board with a series of sockets in it. Those sockets then receive what we call CMO2 cards, and each card forms a different function. So we've got cards for things like actuation, measurement, connectivity, such as 4G or power. We've got complete modularity, so any card can go in any slot. So you've got a wide range of input and output combinations. So if you want to add a large number of a certain type of measurement, that is entirely achievable. Or likewise, maybe one type of measurement and a large range of actuation functions. Again, that's very, very simply achievable. And in terms of simplicity of setup, there's no setup for the inputs themselves. You just simply connect your wires to the card, plug it in, and switch on, and you're ready to go. Configuration of that is done via the EnviroHub installer app, which connects to the device, the control module, via Bluetooth. Now we're looking at some applications of where CMO2s can be used. Its modular nature does enable it to be configured to many different use cases. Some of the common applications we see is monitoring discharges of water, for example, from lagoons into waterways. So that's what we can see here. We've got a monitoring unit that's monitoring the discharge of a lagoon. It might be controlling a discharge pump. So what we've got here is we've got a lagoon being dewatered. We've got a discharge pump. We've got a turbidity being measured here. And if that turbidity goes high, it will cause that pump to switch off, or it will cause a valve to change over. So it can control that. It can also control a sludge pump on a lamella tank, and many other applications within water treatment and water quality monitoring for a CMO2 to be able to take care of what needs to happen. Control can also be automatic or manual, or a combination of both. So for instance, it can automatically start and stop the pumps, or it may be that you wanted to stop the pump and then you want to go for a manual restart. And all of that is very simply configured. We'll now look at some case studies for EnviroHub. So on the left here, this is an installation at a large aggregates handling site within the UK. A lot of activities on site. They've got a railhead. They've got a lot of lorries coming in, collecting aggregate. They've also got a batching plant and an asphalt plant on site. So a lot of activity on site. A lot of surface water collected because of the hard standing, and they were needing a means of treating this and correcting it. So how this works is there is a number of pumps around the site that direct the water back to these two retention tanks here. These tanks, when full, can then the water will then get pumped into a pH correction tank. So remember, I mentioned there was a batching plant on site. There was a risk that the pH, the water could have come in contact with cement particles. The pH could have changed. So it goes through a pH correction process first. It then goes into a treatment tank where it gets dosed with a coagulant and a polymer to enable those flocks to form. That then gets settled out in a lamella tank. The sludge is then pumped into a skip. We can just see a tipping skip here, and then that is disposed with by the client on site. The cleaned water can then either overflow to discharge off site. There's a discharge point next door, or it can then be reused for dust suppression on site and essentially come back around the system. So it's a circular system. This on the right here, this is a CTO3, so pH correction tank. This is serving at a ready mix batching plant. So this is taking wedge pit water that will be typically high pH. So the settlement will have occurred within the wedge pit. The supernatant will then be pumped into this pH correction tank, where it is then neutralized and then discharged into the sewer. Another project, we've not got a photograph on here, large project with about 9 independent EnviroHub systems running on it. That was a piling operation where an eel screen was being installed on a river at the mouth to the inlet to a water treatment works. So it's very, very important that the water that had to be discharged back into the river was definitely clean and safe for discharge, because obviously it would have an impact both on eels that the eel screen was being installed for, and also the risk of it entering then the water treatment works. So that was a significant project where there was a lot of management on site, managing that process, keeping on top of the chemical dosing to enable that water clarity to be achieved to be put back into the river. Now I'm just going to touch briefly on Senteos. So we've mentioned our online portal where the data gets reported to, and that is our Senteos portal, which will display information on your device. So your computer, your laptop, your phone. It's that real-time visibility of the parameters that are being measured and monitored. So flow rate, pH, temperature, pressure, water levels. It can all be measured and reported on here in graphical format. We can also have lamps on here to show if a pump is running or not, and we can also change the dose rate from here if need be in those applications, or start and stop a pump remotely if we want to. It also stores all the data, so we've got up to 10 years worth of data stored, and we can download reports in a PDF or a CSV format. So we've got a full log of whatever has happened to my system over time. It can also send out alerts. So if you reach a limit, for instance, a hard limit or a soft limit, So what we typically would do is set up what we call a soft limit, which is within the limits on your discharge license. So we'll stop discharging when we hit the soft limit so that we make sure we don't go anywhere near the hard limit. And it can send text messages and email messages when those limits are hit. Likewise, should there be a problem with the power and the power goes down, it will send a message to say that it's lost connectivity. And again, you can investigate that to take any necessary steps. Looping back to compliance then, we really need to obviously make sure that your site does comply with the law. Now, one option for sites to discharge is to use what's called a regulatory position statement, or an RPS. There is a number of different RPSs, but RPS 261 allows for discharges from construction sites, such as you might have an excavation. It might have filled with rainwater. You know that it's rainwater, it's clean, there's no other contaminants, and you simply want to get rid of that water. You can do that under an RPS. There are some caveats. You've got to discharge only uncontaminated clean water. You can only discharge to surface water, so you can't put it back into the groundwater. It's for no more than 3 months. And you also need to plan how to minimize the level of any other contaminants, such as silt, entering that excavation and then getting carried through your pumping operation and being discharged off-site. So it's very important that you can back up and prove that you are meeting all of these, but if you can, that is one method by which you can discharge. Now, it doesn't remove you from the obligation to obtain a discharge permit. However, if you are satisfying all the requirements of the RPS, the Environment Agency is very unlikely to actually enforce you or bring any action against you because they can see that you have complied with all of the conditions on the RPS. If, however, you need it for longer than 3 months, or you are needing to perhaps put any kind of treatment process in place, you do need a discharge permit. It's really, really important to get that discharge permit in place. Now, you need to apply for that from a couple of different places. If you are discharging into a watercourse or to surface water, you need to apply to the Environment Agency or their equivalent in Scotland, Wales, Northern Ireland. If you are discharging into a sewer, you need to apply to the Water Authority in that geographic region for that discharge. They are in turn consented by the Environment Agency. Discharging to a sewer is generally easier. It's generally the better option to go for. You've got a broader threshold. You're not discharging it direct to the environment. You are discharging into a contained system that will then be going to a wastewater treatment works for further treatment. So that is definitely the better option if you can manage to do that. It's also very, very key to plan ahead. We've seen a lot of projects over the years where they've not factored in water management and the disposal of that into their costs, which means budgets can escalate. We've seen projects start work and then they've realized that they need a treatment solution in place, and they've then gone to, right, quick, we need to apply for a permit. And unfortunately, there is a 6 to 9 month wait on applications for permits. It's just that sort of that queue. And if you've broken ground on a project and you've then got that 6 to 9 month wait to get hold of your permit, that is incredibly expensive compared to having got it up front in the first place. So the key really is planning ahead and ensuring that water management has been factored into the whole project plan and budget. So that brings us to the end of the main content for today's webinar. Hope that's been insightful. We'd now like to open the floor for any questions. Please feel free to put these into the Q&A box. It's got Q&A loading up here, but one topic or one question that sometimes comes up is, what is driving this whole change in the first place? What is driving the changing in legislation? And there's a few different things affecting it. there's what's called sensitive area designation. So a specific area, geographic location, might be designated a sensitive area, and so there'll be tighter discharge permits in those areas. There's also, within the water industry, we've got AMP8, which is mandating investment in enhanced treatments, such as solids polishing, phosphorus removal. We've also got the urban wastewater treatment regulations, again, mandating removal of nitrates and phosphorus. And there's also the Water Framework Directive and Environment Act 2021. And there's what's called good ecological status targets. Now, that's driving up new permits, really tightening up on contaminants such as BOD, ammonia, and phosphorus limits. And then there's also that surge in enforcement. So like we mentioned earlier, the Thames Water fine, £104 million, significant fine, but intended to be taken notice of, to really try and drive investment, try and get people focused on doing the right things for the whole environment, for everyone really, so that we've got a better environment for everyone with water, good clean water being discharged, and a whole sustainable, more ethical way of working. Okay, it looks like the Q&A is struggling to load. So if anyone has asked a question and it's not being answered, I apologize. We'll try and answer that after this session. So we'll just move on. So to wrap up, in summary, EnviroHub is a modular scalable system designed to assist with temporary water treatment and water quality monitoring. Like I mentioned at the beginning, the typical flow rates where we see EnviroHub operating is from 2 cubic meters an hour up to the low hundreds of cubic meters per hour. Legislation is a changing scene, and enforcement is increasing. We really don't want it to get caught out. And please ensure any projects you've been involved in or are going to be involved in have been well planned, and consider water management and discharge. We'd hate to see those fines coming through. Obviously, they're there for a reason, but they are significant, as we've been hearing. Thank you for attending today's webinar. Hope you found it insightful. Our contact details are on the screen, and a recording will be made available within 24 and 48 hours. It does look like a question has come in, so I'll just try to answer that. So the question is, I was wondering, after coagulation, pH often drops to the acidic scale. Do you need to pH correct before flocculation? So that will depend. As I said, you want to get to the slightly acidic stage for coagulation, ideally, but it can sometimes drop beyond that. It's the coagulation that wants it to be slightly acidic. So sometimes you do then need to raise the pH at the end of the system. So for instance, you might be relatively neutral, you add your coagulant, it drops the pH a bit, you're slightly acidic. That's fine for flocculation. What you then might need to do is just a dose of caustic or something similar at the tail end, just to bring that pH back up. Another comment here, do you also have pH correction at the back of the system for non-pH correcting liquids? So again, I think as we touched there, so we can carry out a further pH reaction within the treatment tank. That is something that's sometimes done. So we might have pH correction at the beginning. We'll then be doing the chemical dosing in the treatment tank, and then we can also dose in caustic or another chemical if needed, if the pH is different, to carry out that at the back end before then going to that settling stage. Another question mentioned the incoming flow monitor. Are we dosing against flow and suspended solids? So currently we are doing flow proportional dosing. We are, however, in process right now of developing turbidity proportional dosing, and so that will be taking into account the solids and the flow. So that is in development right now. We're hoping to be able to roll that out very soon. Thank you for those questions. If there's any other questions, feel free to drop them in the chat. Okay, well, it looks like there's no further questions. So thank you very much for joining. As I said, a recording will be made available. Trust you find this insightful, and thank you very much for attending. Thank you and goodbye.